So one thing about the Jovian or outer planets that's different from the inner or terrestrial planets is all the moons that they have. And well, for Jupiter, it's pretty obvious why it has so many moons. I mean, it's right next door to the asteroid belt. I mean, talk about an opportunity. Little extra gravity, suck those puppies in. The other outer planets also have lots of moons. They're not so close to the asteroid belt, but there are other reservoirs of smaller bodies out there. For example, the Kuiper belt out near Neptune. But be that as it may, it's not the tiny moons that are really of interest to astronomers. It's the larger moons. For example, if we look at the 4 largest moons of Jupiter, the so-called Galilean moons, named because they were discovered by, let's see, Sigmund Freud, Isaac Newton, Justin Bieber. No, Galileo. They were discovered by Galileo. That's why they're called the Galilean moons. Okay? Having Justin Bieber discover anything is actually pretty frightening to think about. Anyways, I digress. So the 4 Galilean moons are either about the size of our moon or larger. In fact, the largest of them, Ganymede, is larger than the planet Mercury. If it wasn't orbiting a planet, I think it would be called a planet of its own. And Europa, one of the smaller of the large moons of Jupiter, as you read in the book, is a giant icy crust underneath which is an ocean of water. And if there is water, there is the possibility, not definitely, but possibility of life. And Io, this little tiny moon, well, it's about the size of our moon, but it's smaller than Ganymede and Callisto. But Io, one of the smaller of the large Galilean moons, is caught literally between a rock and a hard place, or actually a gas ball in a hard place, because it's the innermost of those moons, and the push and pull due to the gravity of Jupiter and the other 3 Galilean moons just sort of gets this poor moon flexing back and forth and gives it a really bad case of indigestion. Heats up the interior, the end result, volcanic eruptions. Not the kind of volcanic eruptions we have on Earth, not good old-fashioned lava, but sort of smelly sulfur stuff, kind of like think molten rotten egg smell, gooey stuff. Nasty, just really nasty. Going to Saturn, the largest moon of Saturn is called Titan, and it's also about the same size as Mercury. Again, if it wasn't orbiting a planet, it would be called a planet in its own right. And Titan has a very dense, interesting atmosphere. And the atmosphere keeps it a little bit warmer than it should be. I'm not saying it's toasty warm on Titan, because it's not. But Titan also has a little bit of a greenhouse effect. Now, it's too far away from the sun to have a significant greenhouse effect. But having a dense atmosphere definitely makes a difference. And it rains on Titan, but it doesn't rain water. It rains things like methane and ethane. Imagine raining natural gas. And the Huygens probe descended down through the hazy, cloudy atmosphere and landed on the surface and gave us some pretty remarkable views of this alien landscape. And of course, other moons like Enceladus, this ice ball, small ice ball, has to be dead, right? No source of heat in the outer solar system. Wrong. Enceladus is anything but boring and dead. It has these tremendous geysers made of water that spew out of it. We really want to send a probe closer to Enceladus. I mean, we have Cassini orbiting around Saturn, which takes pictures of Enceladus every once in a while. But could you imagine a small probe actually landing on Enceladus? That would be wicked cool. And then last but not least, we have Triton. Triton, not Titan. I know they sound the same. I apologize. I did not name them. Triton is the largest moon of Neptune. I like to call it the moldy cantaloupe. If you look at a picture of it, you'll see why I call it the moldy cantaloupe. Anyways, its pinkish orange surface is frozen nitrogen. Yeah, the gas that makes up the majority of our atmosphere is frozen as snow and ice on Triton because it's so cold there. Minus 400 degrees or so Fahrenheit, give or take a few. And Triton is interesting because it's in a retrograde, unstable orbit. It's slowly spiraling in towards Neptune. And it's not actually going to hit Neptune when it gets too close, the tidal forces will break it apart, and Neptune will get some pretty awesome rings to go with the sort of dusty rings it already has. Now, the fact that Triton is in this unstable orbit is a pretty good indicator that it did not form in that orbit. Triton used to be a member of the Kuiper Belt. Triton is a relative of Pluto and its moon Charon, and it wandered too close to Neptune, and we all know what happens when you wander too close to a planet. One of two things. You hit it, or break up his rings, or you get in a nice stable orbit, or semi-stable orbit, or unstable orbit that at least orbits for millions of years before doing something nasty. And that's what's happened with Triton. It was captured by Neptune, slowly spiraling its way in, so we can call this Neptune's temporary moon.